Imagine you are standing in a modern kitchen. You open the fridge, grab a prepackaged meal, and throw it in the microwave. 3 minutes later, you have a hot, calorie-dense dinner. Now, strip away the kitchen, the electricity, and the house. Imagine you are sitting in a dangerous ancient savanna. You hold a fistful of raw, tough tubers and a piece of raw, stringy meat. If you eat this raw, you will spend the next 8 hours just chewing. You will exhaust your jaw muscles and barely extract enough calories to survive. Every other animal on Earth still lives in that raw food reality. We escaped it. We learned to transform our food with heat. What if the spark that created human intelligence was not a biological mutation but a simple campfire? We rarely think about cooking as a biological necessity. We watch cooking shows, read recipe blogs, and treat culinary skills as a form of art or culture. But cooking is not just culture. It is the defining feature of our human biology. The human brain is a massive, energy-hungry anomaly. Your brain makes up only 2% of your total body weight, yet it consumes 20% of your daily energy. It is constantly burning calories, even when you are asleep. For a long time, scientists were completely baffled by this. If a wild animal suddenly mutated to have a brain as big as ours, it would starve. The natural world simply does not offer enough accessible calories in raw food to support such a hungry organ. Look at a gorilla. A silverback gorilla is incredibly strong and massive, but its brain is only a third the size of ours. To fuel its body, a gorilla must sit and eat raw leaves, stems, and fruits for up to 8 or 9 hours every single day. They are trapped in a biological dead end. They cannot grow a bigger brain because they simply do not have the time in the day to chew enough raw food to power it. So how did our ancestors break this evolutionary speed limit? The answer is that we outsourced our digestion. We invented a way to digest food outside of our bodies. When you cook a potato, the heat breaks down the tough cell walls. It turns indigestible starch into a soft, sweet gel. When you roast a piece of meat, the heat unravels the tightly wound protein molecules. The heat does the hard work before the food even enters your mouth. This solved a massive problem for our ancestors. Raw food is incredibly difficult to process. Your stomach and intestines have to work overtime. They churn and produce massive amounts of acid and enzymes just to break down raw plant fibers and raw muscle tissue. This internal processing takes a massive amount of energy. In the animal kingdom, digestion is one of the most expensive things a body does. Once our ancestors started putting their food in the fire, everything changed. The calories became cheaper to digest. Our bodies absorbed significantly more energy from the exact same amount of food. Studies on animal diets show clear results. Animals eating cooked food gain more weight and use less energy digesting than those eating the exact same amount of raw food. We see the evidence left behind in our own anatomy. Look at a chimpanzee. A chimp has a massive rib cage that flares out at the bottom. This wide torso is built to house a gigantic large intestine. They need that massive gut to ferment raw plant matter for hours and hours. Now look at a human. Our rib cages are narrow. Our stomachs are flat compared to an ape. We have incredibly small, large intestines. Over hundreds of thousands of years, because we were eating soft, cooked food, we no longer needed a massive digestive tract. Our guts shrank. This is what evolutionary biologists call the expensive tissue hypothesis. The body has a strict energy budget. If you spend less energy growing and running a massive digestive system, you have leftover energy to spend elsewhere. Our shrinking guts freed up the calories needed to grow a massive brain, and the physical changes did not stop there. Chewing raw food requires enormous mechanical force. Apes have massive jaw muscles that attach to a ridge on the top of their skulls. These thick muscles act like biological straitjackets. They literally wrap around the skull and stop the brain case from expanding, but cooked food is soft. You do not need the bite force of a gorilla to eat a roasted carrot or a piece of cooked fish. Millions of years ago, our ancestors experienced a genetic mutation that severely weakened our jaw muscles. For an ape eating raw food, this mutation would be a death sentence. They would slowly starve. But for an early human eating cooked food, it was not a problem at all. Without those thick jaw muscles clamping down on the skull, the bone was free to expand. Over generations, our skulls grew rounder and much larger. Our faces flattened out, our teeth became tiny. We effectively traded big jaws for big brains. Cooking also revolutionized human childhood. A chimpanzee mother must nurse her baby for 4 to 5 years. The jaws and digestive system of an infant ape are not strong enough to handle raw, tough adult food until they are quite old. This long nursing period means the mother cannot have another baby for half a decade. But cooked food is the perfect weaning food. It is soft and mushy. An early human mother could mash up roasted tubers or cooked fish and feed it to a toddler. Because the infant could transition to solid food much earlier, human mothers could stop nursing sooner. This meant they could have more children over their lifespan. Human populations began to grow at a rate that other apes simply could not match. Cooking literally changed our reproductive strategy. It made us a faster breeding, rapidly expanding species. Cooking solved another massive problem by giving us the gift of time. When you do not have to spend 8 hours a day chewing, you suddenly have 3 hours in the sunlight. This is a profound shift in the daily rhythm of a species. What do you do with those extra hours? You explore, you experiment, you sit together and try to figure out how to chip a rock into a sharper blade. You observe the migration patterns of animals. The time freed up by cooked food became the incubator for early human culture. But perhaps the most overlooked benefit of fire was how it changed our sleep. Apes like chimpanzees build nests in trees every single night. They have to sleep high off the ground to avoid predators like leopards and lions. Sleeping in a tree is not deeply restful. You are constantly balancing, half awake, listening for danger. You rarely enter the deep, restorative phases of sleep for long periods. When our ancestors learned to control fire, the flames acted as a protective shield. Predators are naturally terrified of fire. For the first time in evolutionary history, a primate could sleep safely on the ground. They could lie flat on their backs. They could fall into deep, heavy sleep. Deep sleep is absolutely critical for brain development. It is the time when the brain flushes out toxins, consolidates memories, and forms new neural pathways. By sleeping deeply beside a warm fire, our ancestors were giving their newly expanding brains the perfect environment to wire themselves for complex thought. Picture a dry, dusty savanna in Africa, roughly 1.5 million years ago. The sun is dropping below the horizon. The air turns cold quickly. In the distance, the roar of a large cat echoes across the tall grass. For millions of years, this sound meant absolute terror. It meant scrambling up the nearest tree and shivering in the dark. But tonight is different. A small group of early humans gathers near a rock overhang. One of them strikes a spark. Dry grass catches the flame. They feed it with twigs, then thicker branches. A bright orange glow pushes back the darkness. They do not run to the trees. They sit in a circle on the dirt. Someone takes a thick, starchy root they spent hours digging up. It is too hard to bite through raw. They toss it directly into the hot white coals. Someone else takes a scavenged piece of meat and drapes it over a stick near the flames. The smell of roasting fat and caramelizing sugars fills the air. The fire crackles. When they pull the root from the ashes, it splits open easily. It is soft, sweet, and bursting with easily accessible calories. They eat quickly, tearing the soft meat with their small teeth. The fear of the night is gone. The fire radiates heat, warming their skin. The predators stay far away, watching the strange light with glowing eyes. Around the fire, the humans look at each other's faces illuminated by the flames. They are full, they are warm, and they are safe. They have hours of awake time left before they need to sleep. They begin to grunt, to gesture, to share the experiences of the day. The campfire has just become the first classroom. This was the historical turning point that changed the trajectory of life on Earth. Before the control of fire, eating was a highly solitary act. In the wild, animals do not share meals happily. An ape finds a fruit, turns its back on the others, and eats it alone to avoid having it stolen. Food is scarce and highly competitive. But a campfire completely changes the social dynamic. A fire requires effort to maintain. Someone has to gather the wood. Someone has to watch the flame. Someone has to gather the food. Cooking inherently requires a strict division of labor. It forces cooperation. When the food is finally cooked, it is sitting in the center of the camp. Everyone must come together to eat. The campfire created the first central gathering place. It forced our ancestors to look each other in the eye while they ate. It required them to practice self-control, waiting for the food to cook instead of eating it immediately. This shared experience around the hearth demanded a new level of social intelligence. We had to learn to read facial expressions in the firelight. We had to develop complex communication to coordinate the gathering of wood and the hunting of animals. The shared meal became the foundation of human society. Empathy, language, and social bonds were forged in the heat of those ancient cooking fires. The biological changes gave us the big brains, but the social changes around the fire gave us the minds to use them. Fire and cooking also became our passport to the rest of the world. Primates are fundamentally tropical animals. We are built for warm climates where fruit and leaves are available year-round. Without fire, our ancestors were geographically trapped in Africa. They could not survive the freezing winters of Europe or the harsh plains of northern Asia, but a campfire is a portable climate. It creates a tiny bubble of tropical warmth wherever you go. And cooking meant that even in a freezing winter, if you could find a frozen carcass or dig up a dormant root, you could thaw it, roast it, and extract life-saving calories. Cooking allowed early humans to leave the tropics. We followed the coastlines, we crossed frozen land bridges, we adapted to freezing caves and icy tundras. Fire allowed a naked, weak ape to conquer every single environment on planet Earth. They sat in the dirt, huddled around a fragile flame, chewing on charred roots to survive the night. You sit in climate-controlled rooms, surrounded by endless food options, watching glowing screens. But the next time you hear a steak sizzling on a grill or smell bread baking in an oven, remember where you came from. You are not just enjoying a meal. You are participating in the ancient ritual that built the human brain.